Okay, so today we're going to learn about how to prove that a quadrilateral is a parallelogram. You notice I already have writing on here. It's because I've already done this lesson a couple of times and my camera has acted up. And I decided not to try to do it again, mostly because it was making me nuts. So, parallelograms, opposite sides converse. Basically, you're undoing this. You're trying to say that you have a quadrilateral and you're trying to tell me that this is a parallelogram. If the opposite sides are congruent, then you've got a parallelogram, okay? If the opposite angles are congruent, you have a parallelogram. Now, if you take a look at this crazy amusement ride, it tells you in the problem that this is parallel to this. So this right here is parallel to the ground, and you'll notice that the opposite sides are congruent to each other. So by saying the opposite sides are congruent, this is a parallelogram, which means AB now has to be congruent and parallel to DC. So therefore, it's a parallelogram, and AB is also parallel to the ground. So because ABCD is a parallelogram, and that's true since the opposite sides are congruent, then AB is parallel to DC is parallel to the ground, which they called line L. Okay, so for what values of X would make this a quadrilateral? PQRS, a parallelogram. So I just need to make the opposite sides equal to each other. So x plus 9 is equal to 2x minus 1. And when you solve it, x equals 10. I'm going to need that information to plug into here. So I have y is equal to x plus 7. 10 is equal to x, so I substitute that in. Solve, and y equals 17. On this one, opposite sides are parallel and congruent. So the opposite sides are parallel and congruent to each other. This is a parallelogram. And a parallelogram diagonal converse, if the diagonals are congruent to each other, that would be your midpoint right there, then this is a parallelogram. It gives you an example of a doorway in England. Over time, the building has leaned sideways. Explain how you know that these are congruent. Well, the measurements here still stayed parallel to each other, and as it leaned together, so therefore they're equal. For what values of x and y would make this a parallelogram? You just need to solve for x, knowing that the opposite angles are congruent and the opposite angles are congruent to solve for x and y. And so when x is 32 and y is 29, this is a parallelogram. So, last one. This is a very short lesson. It was short already before I had to redo it for the third time. But state the theorem that you can use to show that the quadrilateral is a parallelogram. If the opposite sides are parallel and congruent, parallelogram. Opposite sides congruent converse, and opposite angles congruent converse. So these are the theorems that you would use to show that these are parallelograms. For what value of the quadrilateral is this a parallelogram? Remember I taught you about diagonals. These two were already given to you as being congruent. So if these two are congruent, or for what value of this makes this congruent, this would make this a parallelogram. So when x equals 2, that's a parallelogram. And below that shows you the 5 different things here that you can use to show that a quadrilateral is a parallelogram. I suggest reviewing and learning those to make sure that you got that. Any questions? As always, please let me know. Talk to you soon.